Circular queue. So before seeing about the circular queue, we will see why we are going for the concept circular queue. So already we saw about the queue. So queue, it is a linear queue. So we can able to implement the queue by using the linked list as well as by using the array concept. Okay. So when you are doing the insertion, so what we are doing, we are doing the insertion in a rear end and we will do the deletion in the front end. Okay, deletion in the front end and insertion in the rear end we are doing. So for example, consider this linked queue. So here the front position is 0 and rear position is 9. Okay, so when we are doing the insertion, we will check the condition. Friend is equal to, okay, we will check the condition friend is equal to null. If friend is equal to null means, so the queue is empty, we can able to do the insertion. Okay, uh, or we can check the condition rear is equal to max minus 1. If it is max minus 1 means the particular queue is full. So if you want to insert any element, any another value means it is not possible because the queue is full. That is, there is no space for doing the insertion. Suppose the queue is like this. For example, the queue is like this. Uh, queue is like this. Okay. So it is indexes 0, 1, 2, 3, 4, 5, 6 and 7. The front position is here. It is in a 2. Okay. So for example, values are 7, 18, 14, 36, 45, 72. So rear is here. Okay. Here, what is the front value? Front position value is 2 and rear position value is 7. Okay. So we are checking the condition, that is rear is equal to max minus 1. So what is the maximum size? It is 8. So we are checking rear. What is the rear value? It is 8. 7. Rear value is 7. It is equal to max minus 1. 8 minus 1. It is 7. So the condition is true. If this condition is true means what is the meaning? It is overflow condition. That is, the queue is already full. We can't able to do the insertion. But if you see here, there is two spaces are empty. That is, we can able to allocate the element here, but we can't able to do it. So that is the main drawback in a linear queue. So to overcome this issue, there is a two solutions. What is the one solution is, we can shift the values to the left side. So when you are trying to shift the values to the left side, that is in a vacant space, it will take more time, and same time if the cube is large, so shifting all the elements in the vacant space, that is in the left side, it is very tough. So that is one solution. And next solution, that is the second option, is we can use the circular queue. So that is, in circular queue, the first index comes right after the last index. So the circular queue, it will be like this. Okay. So it is like this. So if you are starting the index from 0, 1, 2, 3, 4, 5, 6 and 7. So same issue. So for example, here the elements are like this. It is 7, 18, then 14, 36, 2 and 7. Okay. Then in this case, what we can do, if you are trying to do the insertion in, so this is the rear position and this is the front position. So if you are trying to do the insertion, what we can do, we can make the rear position as a 0 and in this place we can do the insertion. So this is the advantage in a circular queue. So we will see the definition for the circular queue. So circular queue is a linear data structure in which the operations are performed based on the first in first out concept, and the last position is connected back to the first position to make the circle. So this is the last position, this is the last position, and this is the first position. It is connected to make the circle, so it is called as ring buffer. Okay, so it is called as ring buffer. So when we will say the particular queue is full, if the front value is equal to 0 and rear value is equal to max minus 1. Okay, if front value is equal to 0 and rear is equal to max minus 1, so in that case, what is this? The particular queue is full. So a circular queue is implemented in the same manner as a linear queue is implemented. Okay, in the same manner we will do the insertion as well as deletion also. Okay.